In this episode, we will discuss the project of widening of existing road from 2-laning to 4-laning. In this, we will see how the existing road is modified and how the proposed road is developed. What are all the components used to develop the roads? Such as subgrade, subbase, wetmix, asphalt, and other miscellaneous items. And what are all the specifications and procedures followed? Welcome to Civil Guru. These videos made in different languages, like English, Hindi, Tamil, and also in Arabic now. Please choose your desired language from our playlist. If you like this video, please like and subscribe now, and share it with your friends. Thank you. Before going into detail, let us have a look into the existing road and natural surface. In general, the proposed roads are taken as a priority to develop the road, because it can be started immediately without affecting the existing traffic. And also these proposed roads can be used as an alternative road while developing the existing road. So, now we will see about proposed road development at first. Before starting of any work, the reduced levels of natural surface shall be taken for record, which will support to calculate the quantity of excavations done during the cleaning process. Usually, a subgrade will need some basic preparation to make it fit for construction purposes, and this process is known as subgrade formation or reducing to level. It is bad practice to construct a pavement over surface vegetation or topsoil as organic material. It will decompose, which could lead to the formation of voids in the covering layers, which could lead to settlement of pavements. The simplest form of subgrade formation is site strip. This process involves the removal of all surface vegetation along with the root zone and any topsoil. Most projects will involve some degree of digging down to a formation level. There are two common reasons for digging: to accommodate the finished levels of paving work and to remove bad ground, soft spots or other deleterious material. After completion of site cleaning, the top surface of the cleaned existing ground shall be compacted roughly, and again, the reduced level shall be taken for record, before start filling the subgrade, to calculate the quantity of embankment filling required. The method of calculation of the earthwork quantity will be discussed in next episode. The next item of work is subgrade. It is also known as embankment. For most construction works, the required pavement thickness is designed and known in advance. Once the finished road level is established, the thickness of the paving can be subtracted, and this will establish the formation level. The formation level is the uppermost surface of the subgrade. The subgrade is the base of the road construction. It will be overlain by the other pavement layers. If the ground is structurally weak, likely to be subjected to exceptional loads, or is significantly below an ideal formation level specified. Subgrades are layers of earthfill from a selected borrow pit. The scope of work includes excavation, loading, transport, laying and leveling, watering with portable water to optimum moisture content, and thoroughly mix it before compaction. The compaction shall be done to the 95% of relative density. For highways, the modified Proctor density is considered to find the relative density. The specifications to follow is: the selected soil shall have the soil bearing capacity of 1 and above. The optimum moisture content shall not exceed 5 to 6%. The plasticity of the soil shall be between 1 to 5%. 0 to 1% of plasticity considered as sand, which may slide out of the embankment during rainy season. And above 5% shall be considered as clay soil, which is also not suitable for roads. The next item of work is a subbase. Most paving relies on supports. The subbase layer is the main load-bearing layer of a pavement. It is designed to spread the load of the paving and any traffic thereon evenly to the subgrade below. The interlock between adjacent particles of the subbase material ensures the ground's ability to carry heavy loads comparatively. There are two different types of specifications are followed for the subbase. One is an unbound granular subbase, and another one is a cement-bound subbase. Cement-bound subbase is a cost-effective way to build a heavy-duty, durable pavement, fast. It offers an alternative to traditional flexible materials. The binder material can be a rapid setting like cement, or slow setting materials like PFA and slag. However, the unbound granular materials are the most commonly used for road projects. Generally, these materials are available in most of the riverbeds. In some country areas, the underneath of natural ground itself has the naturally blended subbase material. The material shall be spread in uniform layers, such that the compacted thickness shall not exceed 200 to 250 mm, with due consideration to loose thickness for compaction factor. Each grader run shall overlap 1/3 of blade length. The moisture content shall be checked for OMC. If it is less than required, then the water may be added by sprinkling, and if it is more than required, then it shall be exposed to the sun until it reaches OMC. The compaction shall be done mechanically, by using vibratory rollers of 80 to 100 kN static weight for the entire width of the pavement. The rolling shall commence from the lower edge, and proceed to the upper side, with 1/3 of overlap. Generally, 6 to 8 passes are required for compaction of 98% of lab density. Each layer shall be tested by the sand replacement method. The specifications to follow in Subbase is: the selected blend of subbase shall be free from organic materials, and shall have the minimum soil bearing capacity of 2 and above. Normally, a good granular subbase materials have the bearing capacity more than 3. The gradation of material shall pass the designated sieve analysis. The maximum size of granular stones shall pass the 75 mm sieve 100%. Means the granular stones used in subbase shall be less than 75 mm in size. The higher properties of subgrade soil shall be blended with granular aggregates to ensure more durability. Normally, the mixture of 1:2 by volume, that is 1 part of granular aggregates, and 2 part of good subgrade soil is blended thoroughly to produces a good subbase material. Here, we will see the role of surveyors. And this type of survey work is repeated in every item of works to control the width and thickness of every pavements, such as Wetmix and Asphalt works. Before the commencement of any item of work, the toe line, that is, fixing of pegs, to mark the limits of granular subbase, shall be done by surveyors. The width of pavement for toe line shall be calculated by referring to the drawings, with due considerations to formation width, plus the offsets and slopes of different layers' depth, and the current layer from the formation road level. Control pegs at every 10 meters shall be fixed on both sides of the bed, in such a manner that they are not disturbed by grader movement. And 5-meter interval pegs are suggested on curves. The required level of pavement top shall be marked on the pegs, with a suitable vertical offset. After rough initial spreading, a cotton or nylon string, which is known as line dory, shall be held at the marks on the control pegs on both sides. The string's height from the bed top is measured at a fixed horizontal offset. The grader operator shall be directed, according to measurement in the above step, to cut and fill at every point. Now, the next item of work is Wetmix Macadam. Wetmix Macadam is the next generation of water-bound macadam, and it is intended to be an alternative and more durable pavement in roads and highway work. It is generally used as a base course of flexible pavement. WMM provides uniform and strong support, high resistance to deformation and distress. Wetmix Macadam shall be prepared, as per approved proportionate of aggregates, in the pug mill plant with controlled addition of water. Water to be maintained within the limit. Generally, 1 to 2% extra over the OMC shall be maintained in the mix, to compensate the evaporation losses, depending upon the lead and season. The mix shall be transported from the plant to the laying site. If the existing subbase surface is found to be dry, water shall be sprinkled before laying of wet mix. Considering the compaction, the loose laying thickness shall be kept 15 to 17% extra. For compaction, the test trail shall to be done to check the number of passes required to achieve the 98% of relative density. The number of passes shall be made as, at the beginning 1 plain pass, and 2 to 3 low vibration pass, and at the end of compaction, again 1 plain pass. The speed of roller during the compaction shall not exceed 5 km per hour. Generally, high vibration passes are not used in Wetmix because it may crush the aggregates used, which may reduce the durability of pavement. Similar to Subbase, the surveyor shall fix the control pegs at every 10 meters on both sides of the bed, and repeat the procedure to control the width and thickness of pavement. The level of finished layer shall not vary from the project design level for a particular layer. The tolerance on surface levels of Wetmix, plus or minus 10 mm. For checking compliance with the above requirement, measurements of the surface levels shall be taken on a grid of 10 meters longitudinally and 3.5 meters transversely along the pavement. The average of 10 measurements shall not be more than 3 mm above the permitted limit. The specification of material to be used for Wetmix Macadam shall be the gravel, 0 to 6 mm crushed aggregates, and the stone, 6 to 50 mm crushed aggregates. The proportionate of this blended material shall conform the grading requirements as per the specification. In India, the Morth V table 400-13 is followed. The next item of work is Curbstone. The Curbstone provides a clear physical and visual marking and delineation. It makes the drivers conscious of the pavements and greenery areas in demarcating roads, streets, car parks, etc. It makes a clear-cut view of the carriageway. It helps in preventing any kind of spreading from the carriageway. There are many types of curbs available. The types are mainly based on the purpose of usage and the type of materials used to produce, and also available in different textures, colors, and standards. Where the central medians are very narrow, there, high raised concrete dividers are used to separate the carriageway. The specifications to follow is: high-strength concrete shall be used for curbstone to withstand the vehicle's load and traffic pressure. Expansion joints shall provide at every 10 meters intervals. Hunching shall provide to support the curbstone. Now, we are going to see the asphalt work. Asphalt work is the most expensive and important work in the road project. It involves the following item of works. First, the prime coat and tack coat. Second, bituminous macadam. Third, dense bituminous macadam. And then, fourth is wearing coarse or asphalt concrete. The prime coat is the binding layer between bituminous and non-bituminous surfaces, such as Wetmix macadam. The cutback Bitumen 70 is used as a prime coat. The material shall be heated around 150 to 160 degrees temperature, and well blended for 2 to 3 hours, and uniformly sprayed around 1 kg per square meter over the dry and clean Wetmix surface with the help of a mechanical sprayer. Normally, it shall be allowed not less than 24 hours to penetrate in Wetmix before laying of asphalt work. The tack coat is the binding layer between two bituminous surfaces. The bitumen grade 80 to 100 is used for the tack coat, and it is heated around 150 to 160 degrees temperature and uniformly sprayed around 0.5 kg per square meter with the help of a mechanical sprayer. Normally, it is sprayed just before laying of next layer of asphalt item. The next item of work is the dense bituminous macadam, DBM. The DBM consists the laying of a single or two layers on a previously primed and approved Wetmix macadam in accordance with project specification. Each layer shall be not more than 100 mm thick. The materials used are coarse aggregates, fine aggregates, and the binder content. The coarse aggregate shall be the blend of crushed aggregates from 6 mm to 25 mm, and it shall be cubical or angular in shape, and it shall satisfy all other specification. Fine aggregates shall be passing of 2.36 mm sieve and retained on 75 micron sieve, consisting of crusher run screening. The important things to know is that a natural sand is not allowed as a fine aggregate in any of the asphalt work. Generally, the 80 to 100 grade bitumen is used as binder content in highways. The percentage of binder content shall be determined to achieve the requirements set out in specifications and the traffic volume specified in the contract. The Marshall method shall be adapted to determine the maximum percentage of binder content. Normally, the percentage of bitumen used for DBM is between 4.0 to 4.5%. Apart from conformity with grading and quality requirements of individual ingredients, the mix shall meet the requirements set out in the specifications of the project. Job mix formula shall be prepared and approved by client before start the asphalt work. The formula should be within the limit and shall satisfy the quality control criteria as per project specifications. After the job mix formula approved, the plant trial should be done to confirm the bituminous mix design. Construction procedures to follow are: weather conditions. The work of laying shall not be taken up during the rainy or foggy weather. And if the surface of base is damp or wet, or during dust storm, or when the atmospheric temperature in shade is less than 10 degrees. Preparation of base. The surface of laying shall be free from dust and foreign matters. Shall be swept clean by using mechanical broom or blown off by using compressed air. The transverse joint shall be cut vertically with an asphalt cutter, and a coat of hot bitumen shall be applied before placing materials. Prime coat or tack coat shall be applied as per the specifications. Preparation of mix. The DBM should be produced on batch basis by weight in hot mix plant. The mixing shall be done in a twin-shafted pug mill which will produce a homogeneous mix. The mixture shall be transported from the batching plant by tippers. If required, covered with tarpaulin to maintain the temperature and to control the dust. Spreading or laying. The mix shall be slowly discharged in the paver hopper, while both the tipper and paver will move forward steadily and slowly. If possible, the paving shall be done in one go for the full width of the road. The normal temperature of the mix at the time of laying shall be 140 to 160 degrees Celsius. However, it shall not be less than 120 degrees Celsius. The automatic sensor shall ensure that the mix is being laid to the proper line and grade and level. This sensor of the paver will be guided by the string lines fixed by surveyors with the stack and arms on both sides 0.5 meters away from the edge. The compaction. As soon as the mix has been laid on the surface, the compaction shall be done with the help of set of rollers moving at a speed not exceeding 5 km per hour, following close to the paver. Rolling sequence shall be as established during the laying trial stretch. The compaction shall be completed before the temperature falls below the rolling temperatures, 90 to 100 degrees Celsius. The joint shall be rolled immediately behind the paving operation. After this, the rolling shall commence longitudinally at the lower edge to the upper edge and parallel to the center line of the pavement. Rolling shall be done continuously until all roller marks have been removed from the bituminous surface. During rolling, the wheels of rollers shall be kept moist by sprinkling water from the water storage fitted with the roller to prevent the mix adhering to the wheels. After final compaction, the tolerance of the surface level shall be less than ± 6 mm. The specifications of selected aggregates shall be as follow. The water absorption of aggregates shall not be more than 2%. The impact value shall not be more than 27%. The flakiness and elongation index shall not be more than 35%. The Los Angeles abrasion test result shall not be more than 35%. The striping value of minimum retained is 95% and above. The next item of work is wearing course, WC, also known as asphalt work, AC. The wearing course is the final and finishing layer of asphalt work. The material selection and the construction procedure is as similar to DBM. But the difference between the DBM and WC is the gradation of the mixed aggregates varies between DBM and WC. The maximum size of aggregates used in WC are less than 20 mm. Around 4 to 5% of filler materials are used to get smooth finished surface. In the projects like airport runways, the lime powder or the cement is used as filler material in order to ensure 100% smooth top surface. The percentage of binder material, that is bituminous content in WC, is slightly higher than the DBM, and this layer is always used to be a single course to the maximum thickness of 100 mm. Now, we will see how the existing roads are modified. Normally, the existing road has the camber and slope at both the sides. When the existing road developed as four laning, the slop on both sides is not required, and it is corrected as one side slope with the camber correction layers. The bituminous macadam is used as camber correction, and it is generally laid in 2 layers. The specifications and the method of construction of bituminous macadam is similar to DMB and WC. But the gradation of the aggregates for BM varies from other asphalt mix. In this mix, the 25 mm aggregates are used as maximum size. And the percentage of binder material, that is bituminous, is slightly lower than DBM. Once the camber correction is completed, then, as similar to proposed road, the curbstone shall be fixed at the edge of the existing road. Then, DBM and WC shall be laid as similar to proposed road specification. Next item of work is shoulders. The shoulder is a necessary part of highways, and it serves several functions. It serves as a lateral support to the highway pavement. It provides a means of protecting the highway surface from the intrusion of water, which is one of the great destroyers of our highways. A wide shoulder provides a temporary parking area for people who wish to stop and enjoy the scenic vistas so readily available. A single layer of road base around 10 cm thick and a thin layer of asphaltic screed is used as topping of shoulders to seal the road base. Finally, the miscellaneous works, like central verge filling, road markings, such as center line and pedestrian crossing, and the fixing of signage shall be fixed before completion of project. If you like these videos, please subscribe now and share with your friends. And also don't forget to press the bell button. Thank you.